Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question which states that a 230 volt DC shunt motor runs at 1000 rpm on full load, drawing a current of 10 ampere. The shunt field resistance is 230 ohm and the armature resistance is 0.5 ohm. Calculate the resistance to be inserted in series with the armature so that the speed at full load is 950 rpm. So solution. So first we have to draw the circuit, and this is a shunt motor. So a shunt motor is given by this. There's the shunt resistance which is connected in parallel to the armature winding. This is the armature. Then here is the load resistor, this RL. This is the armature resistance. Then this is the back EMF EB. This is the armature resistance which is RA, and the armature resistance is 0.5. So 0.5 ohms. So RA is 0.5 ohms. This is the shunt resistance which is 230 ohm. RSH is 230 ohm. And this EB is the back EMF. This is the load resistor, and here the voltage here is what? Is 230 volt. So now in a motor, so now there's one thing I want you to know, is very important. When you are solving all DC motors, all questions on DC motors, the current always flows from this load resistor, that is IL, and enters the armature, IA, and also the shunt. The current always flows from this RL, which is the load resistor, and flows and enters. So at this point, it will divide. A portion will enter this armature and a portion will enter this shunt. You know, there are some DC motors that don't have this shunt field resistance, because some of these motors are series. Maybe that means this resistor is connected in series to this armature. Some of them are long shunt, short shunt. There are different types of DC motor. This is a shunt motor. That's why this is connected in parallel to this. But in all of them, whether series, long shunt, short shunt, in all DC motors, the current always flows from the load resistor and enters the circuit. So let's proceed. Now the current it draws from this load is 10 ampere. So IL is equal to 10 ampere. So we have to find ISH and IL. So we have to find ISH and IA. But first, we have to calculate the resistance to be inserted in series with the armature, so that the speed at full load is 950 rpm. That means there will be a resistor. That will be inserted here in series with this armature. So let's draw the circuit again. So this is the same shunt resistor, RSH, which is equals to what? 230 ohm. Now this resistor, will call it R. Let this resistor be called R, And this is the same thing, back EMF. RA is equal to 0.5 ohms. This is RL. Then here the voltage is what? 230 volts. So now when you insert this resistor here, this from a shunt motor, this motor now becomes a long shunt motor. Or in other words, a long shunt compound motor. So this one is a shunt motor, this one is a long shunt compound motor. So now let's solve this. Let's find ISH. ISH, which is the current that flows through this shunt resistor, is what? Is given by V over RSH. V is what? The voltage here will also, the voltage on this resistor will also be the voltage on this resistor. So it's what? Is 230 over what? 230, which is 1 ampere. Then applying KCL, here, IL is equals to ISH plus IE. IL is equals to ISH plus IE. Then we find IE is equals to IL minus ISH. So now we have IL. IL is 10 minus ISH is what? Is 1. So this is equals to 9 ampere. So the armature current is 9 ampere. Then now we are going to find the initial back EMF. That is the EMF at 1000 RPM. So that is EB1. EB1 is given by V minus IA RA. So this is the formula for back EMF. Then what is V is 230 minus IA is what? We have calculated 9. What is RA? RA is 0.5. (230 minus 9 times 0.5). This is 225.5 volt. Then now we use this relation to calculate the required back EMF, which is the EMF at 950 RPM. So now EB2 is what? Is equals to, if you cross multiply, N2 over N1 times EB1. This is equal to, what is N2? N2 is what? Is 950. Then N1 is what? Is 1000. Then what is EB1? Is 225.5. So EB2 is what? 225.5 times 950 over 1000. This is 214.225 volt. So now we can find the resistance to be connected in series with this armature, so that the speed at full load is 950 RPM. So now we'll use this same formula, but we'll use EB2 here and we'll add the resistance here. So it will be EB2 is equals to V minus IA instead of RA now. That in resistors in series, that means if this resistor is in series with this, if this resistor is connected in series with this RA, the total resistance is the summation of the two resistance of the two resistors. So we will sum their resistance, which is RA plus R. Then this is 230. EB2 is what? Is 214.225. Then this is 230 minus what is IA? Is 9. RA is what? RA is 0.5. Then R is what? R is the unknown. So now we can open this bracket. This becomes 214.225 is equals to 230 minus, so it will be 9 times 0.5. This is 4.5. Then it will be minus 9 times R, which is minus 9R. So this becomes, it will be 230 minus 4.5, which is what? Is 225.5. So this becomes 214.225 is equals to 225.5 minus 9R. So now we'll take this to the other side. 9R is equals to 225.5 minus 214.225. This is 11.275. So R is equals to 11.275 over 9, which is what? This is 1.253 approximately. 1.253 ohms. So this is the resistance that will be connected in series to this armature in order so that the speed at full load is 950 rpm. So we have successfully solved this question. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.